Is it possible you can build R2 in a weekend? Keep watching and see how we get on. These are all the printed pieces you need. So working our way along, we have a dome ring, the dome itself, a body, 2 legs, a dome gear, the wheels for the legs, the servo brackets for the legs, the centre foot and the centre foot caster holder, the centre ankle, the centre foot insert, the centre foot, the battery box components for the main legs. We also have here the dome servo bracket holder, which sits there. So assembly's quite quick. You can build this in about an hour. Only thing I would suggest is you need to make sure that some of these holes are re-drilled. So like this one here, which takes an M3 bolt, I pre-drilled out with a 2.5mm screw. Just pre-drilled it out 2.5mm. And again, these ones probably need pre-drilling out, and probably those ones as well. In fact, actually no, that doesn't, because that screws into there, and you want that into there, so that's fine. That one's actually all right. There was another thing that I needed to pre-drill. Oh yeah, don't worry if it looks like that underneath. That's just my printer, but it's still fine. You're not going to see it because it's all on the top. There's something else I need to pre-drill. Oh yeah, here. So you can see here underneath. You can see here underneath. That is what Mike's called sacrificial layer. So it's printed like that. Sacrificial layer in order to make this bit. But we need a screw hole there. At the top there, and that didn't print very well at all, did it? So I'm just going to pop that through. And that will enable us to put a screw through there to attach the centre ankle. That bit. So printing wise, these are all printed with a 0.2mm layer height, and the details quite still visible. Infill was, I think I did about 20% infill on these, and only about 3 or 4 walls. I did more walls for the gears. I went up to about six walls, and I upped the infill to 25%. But to be fair, these aren't under much load. What you'll also need are some FS90R continuous rotation servos. These are like the MG90s or the SG90s, but will continuously turn around. You need some 683ZZ bearings, some 625Z bearings, those are the wrong bearings, and some M3 screws. You need M3x5, M3x8, M3x10, M3x10 grub screws, M3x20, and that's it. We'll get to electronics later, but you'll need a battery and some sort of way to control the servos. There's 2 ways of doing it. You can use a 6-channel transmitter and receiver, and that'll work fine. You won't have any noises. Or if you want to be really awkward, you could design a PCB board that will use one of those. And these are from the kits, so they've got small hands. So essentially, that's fine for them. They can move the droid around, and there's a DF mini player on there, so they can make a noise and rotate the dome. That's perfect for them. Might even make that dome rotation, but either way, that's fine for them. So these are left over from my old BB-8, and I've got 2 of those because there are 2 droids. So put that to the side. We'll cover these later. I'm not quite sure how this is going to work properly yet. So the first thing we need to do is make the legs. So we can move these to the side. Those. Not need those yet. Not need those yet. Those all that. So the first thing we need to do is assemble the servos. Well, faffing with the tiny little plastic bags. Right. need the screws, and you need the circular servo horn. And the servo horn pops in like that. So you've got the flat edge. Yeah, you've got the flat edge of the wheel like that, and the servo horn pointing out this way, and then you'll be screwing onto the servo. So what you can do is two-part epoxy it in, but what I ended up doing is just running a little bit of super glue around the edges, because you can see this one's actually spinning in place. The pre-built one I did, test dry run, wasn't spinning in place. It was a lot tighter fit. So that's, again, printed on 2 different printers. So I've just glued that in like that, and that should hopefully hold it in place. As I said, they're not under that much strain, really. I think the other one. And I always keep these bits because they're interchangeable on any small servo generally. And I've got a load of these screws hanging around as well, because these screw heads tend to strip out on the top. So I've got a load of spare ones somewhere. So it's worth keeping them, even if you've not used the servo. Right. So the 2 leg brackets, they are mirrors of each other. You can see there's like a little, I don't know how that'll show. Side on will show better. Or not. There's a little cutout there. And then on the other one, cutouts on that side. And they are because they are left and right. So with the cutout on this one, I'll tell you what, let's label it so we can. Right. There we go. Right, on number 1, we've got the cutout on this side where I just marked. We want to mount the servo head, servo shaft, closest to that cutout point, and mount it this way. So the servo bracket holder, and then the frame itself, and we're going to screw through that way. So we take the longer screws. And as always, servo wire is always awkward. And just screw that one down tight. There we go. And then on the other one, same thing again. So we've got the cutout here, and mount the servo that way round. So essentially the wire is going to go underneath that cutout like that. There you go. And you don't want any play in the servo. You want that as tight as you possibly get without stripping the servo head off. Right. And glue this in. And we'll just leave those to set for the moment. Next step is the feet. And we need to glue this bit onto here. These are identical. There's no left and right. Actually, there is a left and right. He says there's a left and right. Hang on. I didn't do this on the other one. Right, there is a left and right. Sorry. So if we're looking at the leg like that, with the tilt going back away from us, then we want the cutout to be following the same, to be at the top of the tilt. So the cutout top of the tilt. So we need to glue that one like that. And glue that one like that. Now, the instructions do say you can use a bit of filament to push it in, but I don't think it really matters because I'm going to glue it using this and have the same effect. So just line it up. It's already gone squidgy, so that's a good sign. It's already starting getting hard to move, which is no good sign. So just push it in. Yeah, don't worry about the fact it's blue. That's stains from a previous episode where I was re-gluing stuff onto a pre-painted horseshoe. That's lined up. Yep. Leave that one to dry. Leave that to dry for a few minutes. So we're going to mount the servos in now. So the cutout on the outside, and you want that cutout to be following the cutout on the inside of the wheel, of the foot there. Yeah? So the cutout will follow. So you move the servo cable around like that. Well, in fact, what you first do, put the servo cable in that hole there. Feed it all the way through. And providing it behaves, it should pop out the other side. Just feed it through. And then making sure that the cable stays there. We'll feed it through like that. So that's how that would go in, with enough room for the wheel. Obviously, I'm not going to screw it in yet because I need to put the wheel on. It's probably dry enough. So again, we just put the servo horn on. Get a teeny tiny little screw. Yeah. Okay. Wasn't dry enough. Hopefully that'll dry now and stay stuck. I'm expecting this one to do the same again now. Should have really put the glue behind the servo horn the first time. It's done the same thing again. Right. I'm going to leave those to dry properly. Leave those to dry fully. So while waiting for those to dry, we can start working on the centre leg. So we need the caster, the wheel, ankle, the shell, and the foot block. We'll also need M3x10 grub screw. Now we need an M3x20, which I've got here somewhere. There we go. An M3x20 countersunk screw. Right. So the foot block just drops in there like that. And then you can see that the hole on the foot block is not central. You then take your ankle, and the hole for the ankle is also not central to the ankle, and you've got this little sort of ledge here. That ledge goes over the shortest part of the ankle. Sorry, the ledge goes here, like that. And then you take your M320 and drop it in the hole in the middle. And then they should self-tap. Okay. Right, now we need a 625 ZZ bearing. And then that pushes. Right. This will need gluing. Just a tiny bit of glue because I don't want to get any glue on the inner ring and on the inner bearing. There you go. Just glue that in, and that just sits in there like that. So that can be left to dry while we build the centre ankle, the centre foot. So you need a 683 ZZ bearing, just a single one at this point. You will need 4 of these total. Add on those. And that's obviously it doesn't fit.
Five minutes later.
There we go. As you saw, I pre-drilled the hole out. Well, after scraping it out, I used a 7mm drill bit, and that pushed in. I'm thinking this is actually the centre wheel for the other droid, where I had to pre-drill a lot of holes. Whereas the centre foot on the other droid, it just went in and actually kept popping out, which doesn't matter too much on the centre wheel because it's held within this bit anyway. So that side. Just get mixed up. So you take your grub screw and we're gonna thread it through here. Essentially, we're going to use the grub screw to create an ankle. So we're just going to start it off by getting it in through the first bit of the ankle. Then we're going to drop the foot in. And then just screw it through. So it goes through the centre of the bearing. Okay. And then should then catch on the other side of the ankle, the other side of the caster. There we go. Next little caster. And then that gets pushed into there. Like that. Nice and easy. And then that will sit, make it sit back round. So the slope facing backwards, there's that way, like that. So what I will do is, this print failed, it's currently printing a new one now. So what I will do is skip ahead. We're going to get the last servo out of here. Get the servo bracket and get the servo horn out again. And this is the dome gear. And we're going to do the same thing again. So the horn connection point points away from the gear. So we're going to glue that in again. And I'm going to do it this way, straight away. And leave that to dry. Right, let's get the drive wheels in. So as I said, the slope has the cable running along the slope. And that slope. I'm so confused. And that slope needs to match the slope here. Yeah. Oh. You know what I didn't do? That would make things easier, wouldn't it? See how that all lines up now. So we've got the wire coming out this recess here, going underneath, just about, just under through that slope there, and coming out the other side here. So just hold it into place, and then we need some M3 times 5 screws. I have somewhere. Oh, M3 times. I'm sure M3 times 5. Hey, is that M3 times 5? Yeah. Right. So you take your M3 times 5. You need 2 of those per leg. And you're going to attempt to get it in position, and it's going to self-tap into the plastic. And just pushing the wire to make sure it stays underneath that ledge so the wheel doesn't get interfered. No, it's fine. Yeah. Sorry, I thought I hadn't put the screws on the servo horn then. You kind of need to put pressure on the servo to hold it in position.
1 minute, 37 seconds later.
Okay. Two drive wheels. So just got to wait for that bit to print now, and then we can carry on. So this is the dome servo bracket. And we need to mount the servo in it. Now, if I remember right, so I feed the wire. I feed the wire through there. So you can see the little cutout for the wire. That's so you should be able to get the servo in and then slide it up into position. You want the servo head, the servo shaft, inside this cutout here. And then all you do is you get the servo screws and screw it down. Make sure it can't move. Don't put the horn on yet. So we get the body. And we pop this in here. And you turn it round so that the cutout section is against the body here. So that'd be the leg there. That's because the gear is going to sit here. Gear is going to sit here. So we need M3 times 10. And these should self-tap. Into the plastic. There you go. Next thing to do is take the servo horn, which should have dried. Pop that on. Yep. So it's on like this. Take the little screw for the servo horn. Okay. Right, next step is you want 3 more of the 683ZZ bearings. You'll notice I only have 2 in my hands because I test fit one already and it just went straight in. And you drop 3, well actually, let me explain. They dropped straight in, but on my first build they didn't. And I got a 7mm drill bit and hand drilled it out so it fit it. And then I had to push them in at this point. With these ones, they are press fitting in. Okay. So press fit. That's not coming out. So that's the dome mechanism ready. Only the real R2 is that easy. So now we need to put the legs on. So we start by making sure the body's the right way around. And R2's body, so you thread servo wire in through there. What we also need is an M3 grub screw, M3 by 10 grub screw, and it goes into the top hole. And on the legs, it should require screwing in. There we go. Like that. And then we need another M3 times 20, which will go through this hole here. Why is that not a hex head? Right. M3 by 20 should pop through. And then, as I said, you feed the servo wire in through like that. You line up the grub screw with that one, and then the M3 by 20 will go through that hole there. So all the grub screws doing is just lining up for you to be able to do this. to see it on that side. And that hex head gives a very good approximation of the centre hub on a real R2. So repeat for the other leg. Okay. Last thing we need is the centre foot, and again we need another M3 by 20. Hex head. Right, there's two ways you can do this. You could just glue that foot in, but if you ever need to make repairs to the foot, you kind of screw it. So just pop the foot in into the hole like that, so it's sitting at that angle. So he's now sat in a normal three-legged position. You also need to put this screw into the hole that we pushed out earlier. Okay. Not easy to get the screw in there. There we go. It's not poking out yet. There we go. That's now poking through there. And now we can attach the foot the right way around. Hopefully this should self-tap. Always my worry when it comes to self-tapping is that I might have got a bit of super glue on the inner race of this. There we go. Just a tiny bit of super glue, but just broke the. That's better. Yeah, just a tiny bit of super glue, but I broke that little bit of contact it had on the inner ring. Right, so that's the main body built, and these wires we'll deal with later. As I said, there's two ways of doing this. You can either use which you can't see off screen. You can either use a 6-channel transmitter like a FlySky or one of the sort of throttle ones, or you can go down the route of using a Bluetooth controller on your phone, which there is a version on the Michael Badley Patreon that's just coming out. I was in the middle of designing this when that came out, so I'm stubbornly sticking with this. Essentially the same idea: an ESP32, a DF mini player, and then a right, left, and dome connections for the servos, and then if I want, I can add lights in later. And then we've got power and power and speakers. Right, so that's the body ready. Got all the servo wires we need. Everything's all nice and tight and it's moving. So now we need to move on to the dome. The dome is actually really easy. Right, take another M3 times 20 and screw it through that hole in the middle. and it will need to self-tap because this has now become your dome shaft for it to spin on. The last thing it needs to do is put this dome ring in here, slope facing. Well, it will only fit one way. You've got these screw holes here at 3 points, and they line up with the 3 screw holes there. And then we need M3 times 8. Three of those. Oh, heck's good. And again, these should self-tap. Right. There we go. This is the hardest bit, lining up the 2 gears and getting that point where they'll just click together. I do find putting a Allen key just to push the servo gear aside very, very slightly. I'm using a screwdriver. There we go. It's on. Right. So those of you at Celebration might recognise these. These are the ones we had driving around in the steam room upstairs at London. And yeah, so they were just running on 6-channel remote controls, and they were just there for the kids to play with. Well, big kids. But this is essentially all they were. And then inside is just in the case of the ones at Celebration, was just the 6-channel receiver and the battery. And just driving around. So this is maintainable, as in, if the servos go, you can quite easily remove the servos and put new servos in, and they will wear out eventually. Depends how hard you drive it. But yeah, that's pretty much it. As I said, I've made these for my kids, so when it comes to painting, I'm not going to prep them too much. So all I am going to do is give them a really quick sand over with a sanding block, and then prime them, and then maybe spray them white, or if their kids want them in a different base colour, paint it in a different base colour, and then they're going to go over it with acrylic paint pens. So if, like, just do like the pie panels or whatever design they want to do on them. So these are ready for painting, and now it's control systems. I'm going to start with the electronics now. As I said before, these are the boards that I designed. They're relatively simple. It's just an ESP32 DFME player with a resistor, which I think is a 1K resistor off the top of my head. Then connections for servos, connections for lights as well, labelled up for signal, voltage and ground. And then we have speakers and battery, which I haven't labelled, but I will tidy up the labelling for the Gerber files that I'll make available for use. I'll also make available the code once I finalise the code. So for each board I'm going to need 2 of those, and I'm going to need some of these header pins. I need those header pins as well. We'll be using these header pins for the servos, these header pins for the connections for the ESP and the DF mini player. I'm going to spare you my soldering because it is awful, and you don't really need to see me soldering and making a hash job of it, but I'll show you what it looks like afterwards. Battery wise, I'm using a 4.5 volt chargeable battery. These are the same ones that were used in the droids at Celebration, and basically they just look like that. So they're 2,400 milliamp hours, the equivalent of AA's. Oh, sorry, 4.8 volts. So just under 5 volts, which means I don't need to worry about any step downs for here. And they come with a charging circuit. Say a charging circuit. They come with a USB charger, which I seem to remember has like an LED that lights up when it's charged and not charged. I have some little speakers, and they'll be coming out and making the noises from the DF mini player. I also have somewhere in here the corresponding battery connectors that I'll need for this battery connector, and that will just go into one of these. So I'll solder it all up, and then you can see afterwards what it looks like. So they're soldered up, and as you can see here, we've got these header pins for the ESP, these header pins for the DF mini player, and the sticky out pins, official term, for the servos. I've got a 1K resistor here, and then we've got here, which is the power and speakers. And I need to mark on there what they actually are. So it's not going to show positive and negative. So as you can see on this one, I've already put the SP in and put the power supply in. Might need to tighten that screw down a bit more, but and then the DF player. This is a Duff one, but so it's sitting like this. So it's a very simple board. And then the speakers. Don't think it matters which way around the speakers go. And speaker come out here like that. So I don't think these are charged actually. Let's find out. Oh, that's entertaining. Positive and negatives the other way, the other way around. Right, so I don't think these are charged. So, oh no, we have a light. We have power. That's good. Don't have any power there though. Saying that, I think this one's actually Duff. This is a brand new one, so it should be okay. So it's 4.9 volts. So hopefully I'm not going to burn anything out. Let's have a look. There was a distinct lack of activity on that MP3 player. I was expecting it to flash. Put back into the right place. Just check. We've got ground. We've got ground. Okay. Right. Anyway, we've got power here, so I'm assuming there is power going around. I don't know. So that's good. Okay, so I have power. That's the important thing. I basically need to get the program sorted, so we're communicating on Bluetooth from here to talk to one of these. These also need charging up. And then from there we can make sure the program's working. That if I do a trigger button, it plays the sound from here. We also need 2 SD cards. Those are both in the same position that I want them to be in. So now, as I said, it's coding. Right, I've got the coding done, I think. So we're just going to test it. I've got the right leg, left leg, dome. Got the speaker plugged in. So just going to carefully work out how I'm going to get this in here. Not a lot of room. I mean, to be fair, once it's in, you shouldn't really take it out again. Right, speaker for now, will just pop in there. And I think the battery I'll have on this other side here. Easier access. The battery's now charged, I think. Ooh. Something. So let's have a look. Connect the remote. I'm assuming you heard that. So press up, we should get a noise. Now at the moment they're test noises, so all I've done is just taken the Padawan sounds and dumped 36 sounds in. But the idea is going to be that, a bit like the Human Cyborg Relations app, so there'll be happy, angry, sad, scared, and just random sounds within those brackets. But now the speaker's not brilliant, and I got a funny feeling these are not the speakers. I don't think these are the speakers I originally bought for them. These were I bought for the PKE meter. I thought I had some other small 3-watt speakers, but I don't. So I'll order some of those and replace these speakers with those. But we'll see. Right, so, and then for the shoulder buttons, and then for drive, oh, so that's working. There's a bit of I need to put a bit of dead band in there because that's picking it up as a move straight away. So I need to put a bit of a dead band in there. I'd probably put that in the mapping of the joystick and say if it's. Well, no, I can't because I'm doing minus 127 to 127. I'll have to put a dead. I'll have to work out how to put a dead band in there. But it works. So let's put his head on. Somehow, this is the bit I don't like. It's very tight. That. There we go. Right. It's not loud, but yeah, my kid's going to love this. So the sketch is using a library I found on the interwebs on GitHub for the PS3 controller and ESP32. Most of it I just cribbed from there and used it to map to the servos. So essentially, it's reading the directions and how much I'm pushing forward, and then mapping that to how far to push the servos, either in the forward or the reverse, because obviously the servos are flipped the other way, they're mirrored. So forward for one is actually reverse for the other to get it to move forward overall. And also then and then for the mixing, I actually had to refer to another BBR2 code written by Dan B. I'm not sure it ever went into use, but it had a lot of helpful stuff in there, and that enabled me to get this bit to work. Incidentally, the sticking of the turn, I think it's a center caster. Yeah, definitely get that band sorted. Yeah, so it's an amalgamation of what Dan B had originally written and the library for the new ESP32 PS3 controller. I then added in the DF Mini player. I added in the DF Mini player controls, so emulating the human-cyborg relations. The only thing I haven't got working yet is I want this to be a disconnect. Now, by default, if I hold down that PS button for about a minute, it disconnects. It then won't reconnect, not without recycling the power. I think that's actually a limitation of the library. Doesn't seem to be a mechanism to do on disconnect, start searching again for a reconnect. I might be wrong. It might be there somewhere. I just haven't seen it. I know the Shadow can do it, but the Shadow library won't work on the ESP32. Or I haven't got it to work on the ESP32. Also, the Shadow library's huge for what I need. I mean, I'm only using half the buttons. I don't need the button combinations. At the moment, these aren't doing anything. I might actually put them to be auto-rotate and auto-play sound, just like an R2 does on Padawan. I might pop that in as an optional. Honestly, I don't think the kids are bothered. They'd be quite happy just doing this. I think they'll be able to use it with their hands, because it's fine for me, but they've got small hands. So, yeah. So the only thing left to do is sort the dead band out, and that's just a coding thing. And I need to get the other one coded up. Essentially, it's the same code. All I do is just get the MAC address off the other controller. Which reminds me, to do that, see, this is the problem. I can't lay it down. Yeah, I need to trim those. Yeah, to get the MAC address of the controller, there's another script that you put on the ESP32 to begin with, and essentially it's looking for any PS3 connection coming in. It's the pairing mode. You make sure it's plugged into your computer with the serial monitor running, and then it'll allow any connection from any PS3 controller, even a normal twin joystick one, and then it displays the MAC address. You then copy that MAC address out, put it into your other sketch, which will be living on here eventually. Reflash it with the sketch, and then when you hit connect, that should then connect. I've written into the sketch that when it connects, it plays a noise, so you know it has connected. Also, likewise, if it has connected, the light's red. If it's flashing, it hasn't connected. The other thing I have noticed is sometimes it has trouble connecting, and the only way to reset it is to disconnect the power, leave it for a few seconds, turn it on and off again, and then reconnect the controller, and it'll work. But other than that, that's there. The rest of it's just tweaking. So I think what I'll do now is I'll get this one coded. I'm going to have to charge the other controller up anyway. Should I wire in a on-off switch? That might be a good idea. Rather than unplugging the power, I could just wire in an on-off switch. Where the hell am I going to put an on-off switch? Underneath. I'll think about an on-off switch. I know these don't generally have an on-off switch. You just pull the head off and disconnect the battery. Battery disconnected, and then give it a second. There we go. That's now turned off. It's realised there's not connected to anything. And then to reconnect, just so it, if you did hold down that PlayStation button for a long time and it disconnects, you'd have to do this and plug it back in. Essentially, if it's brand new. It's now reconnected. Obviously, you can have whatever noises you want when you load them onto the SD card, the DF player sees the files in the order that you upload them. So the first file you upload is always going to be file 1, regardless if it's labelled 001 or not. I think that still holds true. Yeah, so if you want to put 36 files on, you need to select the 36 files and you need to shift click number 1 and then down to 36 and then dump them in, and then it will write them in from 1 to 36. If you want to be extra sure that Windows hasn't cocked that up somehow, copy them over one by one in the order you want them to appear in. And I've done them in batches of 9, so 1 to 9's in here, 10 to 18, 19 to 27, God, I think then, and 28 to 36. And that's how I've done that on there. And then the power on is just a random sound that I picked. So I think I picked sound 5. So that's the way to do that. Like what I'm going to make the code available. The original Dan B code is open source. This is open source. So I'll also make the Gerber file available once I've altered the silk screen to show where things are plugged in and what size connections need to be in and that sort of thing. Documentation. So the pairing code I'll put a link to it, or actually I'll just put a copy of the INO file on. There'll be a copy of the INO file for this. There'll be a link to the Gerber file that you can download, so you can order your own boards of PCBWay or JLC PCB or wherever you get yours done. So I think we're good. I'll sort out the other one. I've done some coding updates and I put the trim code in. I missed it out in the original Dan B code. Let's get these on. There we go. Right. Play completely random sounds. And as you can see, the trim hasn't really done much. Yeah, for some reason the first one seems to be going a bit nuttier. Yeah, I'm having a look at that code because this one seems fine. This one's got the jiffers in it. So yeah, I'll update that code so it's the same as this. I think that's it. So I can let the kids loose with them. But I'm really pleased with them. They're quite quick to make. I mean, it took me about an hour to build these. And then once I had all the coding done, it took me about 10-15 minutes to solder it all up and put it together. And these are charged and off they go. Yeah, droid racing. Okay, so yeah, that's pretty much it. So that's it for now. I'd say, including these, you're looking at about 30 quid, which is not too bad to be honest. And most of that's probably going to be the battery and the controller, and then a bit of filament. As I said, I'll put the Gerber files up for the controller and the code for the actual controls themselves. And yeah, I hope you can see more of these. So, oh yeah, something I should point out. Why are you doing that? Something I should point out, there are lots of different domes. There's the R2 dome, R6 dome, there's a snowman, there's a pumpkin, I think there's a ghost. There's domes for all the different types of droids when they're all done this kind of like Funko, chibi style. But these are only available on the £5 a month and up tier. They're not available on the £1 a month tier. There's a separate link to get these. But well worth it because these are a lot of fun and my kids are going to have a lot of fun. Thank you very much for watching. I hope you enjoyed it, and I'll see you on the next one. Bye for now.